Welcome to The Explainer. Today, we're going to tackle one of the most fundamental building blocks in all of Java programming, methods. We'll show you exactly how to use them to write code that's way cleaner and a whole lot more efficient.
So here's our game plan. We're going to start with the why. Why even bother with methods in the first place? Then we'll get into the how of building them. From there, we'll dive into some advanced stuff and even touch on a really cool kind of mind-bending concept called recursion. We've got a lot to get through, so let's just jump right in.
Okay, so first things first. Before we even look at a single line of syntax, let's ask the most important question. Why do we need methods at all? What's the big problem that they're here to solve?
Imagine this scenario. You've just written this brilliant chunk of code. Maybe it calculates shipping costs or something. It works great. A little later, you need that exact same logic in a totally different part of your program. The easiest thing to do seems to be just copy and paste it, right? But what happens when the shipping company changes its rates? Now you have to hunt down every single copy of that code you made and update each one. It's a total nightmare, and it's a classic sign that there's a better way to do things.
And that leads us to a really foundational principle in all of software development, DRY. It stands for do not repeat yourself. The idea is simple, but it's so powerful. It means that any single piece of logic should live in one and only one place in your code. When you stick to this, your code becomes so much easier to manage, to fix, and for other people or even future you to understand.
And methods? Well, methods are our secret weapon for staying dry. The best way to think about a method is like a recipe. You write down the recipe for a chocolate cake once. Then anytime you want to make a chocolate cake, you just follow that recipe. You don't reinvent it from scratch every time. It's the same with code. We package our logic into a method one time, and then we can just call that recipe whenever we need it.
All right, so we get why we need them, but how do we actually build one of these things? Let's break down the anatomy of a method, piece by piece. You can think of a method as a little mini factory. The return type, that's the finished product that comes out the door. The method name is just the name on the factory sign so you know which one to call. The parameters inside the parentheses, those are the raw materials you have to feed into the factory. And all the code inside the curly braces, that's the assembly line where all the work actually gets done.
But, not every factory actually produces a physical product. Some just perform a service. Maybe a method just prints something to the screen or saves a file. It does something, but it doesn't give you a tangible value back. For those situations, we use the void return type. It's basically a sign that says, hey, we'll do the job for you, but don't expect anything back at the end.
Now, let's talk about that static keyword. This is a big one. The hostile fridge analogy here is just perfect. A static method is like that shared fridge. It belongs to the entire building, the class, not to any one specific room or object. You've probably used static methods without even thinking about it, like when you call math.random. You don't have to create a new math object first. You just call the method directly on the math class itself. That's static in action.
Okay, so we know how to build a method. Now let's figure out how we get data into it. This is a super important concept, and honestly, it's something that can really trip people up when they're starting out. But don't worry, we're going to make it really clear.
This slide right here gets to the heart of it. In Java, there's a huge difference between simple data types, we call them primitives, like numbers, and more complex things like arrays, which are objects. When you pass a primitive, like that integer x, into a method, you're giving the method a photocopy. It can do whatever it wants to that copy, but your original x is completely safe. But when you pass an object like that marks array, you're not passing a copy of the array, you're passing a copy of its address. So the method knows where the original array lives, and it can go in and change it.
Let's just stick with that homework analogy because it's so good. With a primitive, it's a photocopy. Your friend can draw all over it, your original is still clean. With an object, you're giving your friend the location of your homework in your backpack. They can literally reach into your bag and change your original paper. Understanding that difference is a total game changer for how you write your programs.
All right, we've got the fundamentals totally down. Now let's get into some of the more advanced techniques that make our methods way more powerful and flexible. This is where we start moving from just writing code that works to engineering really elegant solutions.
So let's say you're building a calculator. The first thing you'll probably need is a method to add two numbers. So you make a simple sum method that takes two integers, a and b, and returns their sum. Easy peasy. But what happens when a user wants to add three numbers? Do you have to create a brand new method with a different name like sum3numbers? Nope. You can create another method with the exact same name, sum, But this time you tell it to accept 3 parameters. This is called method overloading. Java is smart enough to look at how many arguments you provide when you call sum, and it automatically picks the right version for the job.
But you can probably see where this is going, right? What if someone needs to sum 4 numbers, or 10, or 100? Are we really going to sit here and write a different version of the sum method for every single possibility? That would be absolutely awful. It totally violates that DRI principle we just talked about. There has to be a better way.
And there is, introducing var args, which stands for variable arguments. This is like a magic trick. By adding those 3 little dots after the data type, you're telling Java, hey, this method can handle as many of these as you want to throw at it. 2 numbers, 10 numbers, 1,000? It doesn't matter. Var args just scoops them all up and packages them into an array for you. It's the ultimate in flexibility.
So we've seen how to make our methods more flexible. Now let's explore a completely different way of thinking about problem solving. This is a technique that can be incredibly powerful and elegant. It might bend your brain a little at first, but once it clicks, it's a game changer. Let's talk about recursion.
The best way I've heard this explained is with Russian nesting dolls. To open the biggest doll, you first have to open the slightly smaller one inside it. And to open that one, you have to open the one inside it. You keep doing this until you get to the very last doll that can't be opened. Recursion is the same idea. A function calls itself to solve a smaller piece of the same problem over and over until it gets to a piece so small that it can be solved instantly. The textbook example of recursion is calculating a factorial. The factorial of 5 is just 5 times the factorial of 4, and the factorial of 4 is 4 times the factorial of 3. You see the pattern. But this can't go on forever, or the program would crash. Every recursive function needs an escape hatch, something we call a base case. For factorials, the base case is simple. The factorial of 1 is just 1. When the function hits that point, it stops calling itself and starts to unwind.
Let's just trace what happens with factorial of 4. First, it calls itself to figure out factorial of 3. That call then calls itself to find factorial of 2, which then calls for factorial of 1. And boom, we hit our base case. Factorial of 1 just returns the value 1. Now the magic happens. That 1 gets passed back up, so 2 times 1 is 2. That 2 gets passed up, 3 times 2 is 6, and that 6 gets passed back up to the top, where 4 times 6 gives us our final answer, 24. It just unwinds itself.
Okay, we have covered a lot of ground here. We've gone from the very basics all the way to some pretty advanced stuff. But the absolute best way for this to all sink in and really stick is for you to get your hands dirty and actually try it out.
So it's your turn. Here are a few classic programming challenges that are perfect for practicing this stuff. Pause the explainer here for a minute and just think about how you'd solve each one. For something like the Fibonacci series, for instance, would you use a simple loop, or could you come up with a really elegant solution using recursion? There's often more than one right answer, so have some fun with it.
Look, getting good at methods isn't just about making your code work. It's about learning how to write code that's clean, efficient, and that other people can actually read and maintain. It's about starting to think like a software engineer. We've shown you the tools. The only real question left is, what are you going to build with them?